Uh, Hi, good afternoon. Good afternoon, my dear YouTube friends. I hope you people are doing good. Priyanshi Thakur, Meenakshi Devi, and Aksha. Okay, so it's very nice to see you guys here. So, good afternoon, everybody. Right? So, I would like to start the class without late. So, let me tell you some of the important points what you people need to remember. Okay. So I just want to know like whether you people are audible, whether you are able to hear me or not. So yeah, please do check me in the chat box if you are clear. Good afternoon, guys, YouTube friends. Okay, so let me tell you about me. Like I hope you people are doing good at your home. Okay, so today we are going to talk about some of the important things. Okay, like today is National Girls Child Day. Okay, that's a very good event for everyone to know, right? Yeah. So in the chat box, please do reply so that I can. Actually, saying, sir, I'm unable to join from the link. Okay. Just a minute. I'm sharing the link with you. Can you join now? Yes. So Nazir Ahmed is also joined. Okay. So Meenakshi, to please do check, ma. Okay. And Aksha, Priyanshi, please do check. Right. Hi Nazir, how are you? Is it happening to everyone or I didn't get anything from? Hello, good afternoon, Nidhi. How are you?
Hi, hi. Good afternoon. I'm doing well. How about you?
I'm also doing good. So, like basically, what happened like today one, we had some Zoom technical issues started, so that's why we are sorting it out. So in the meanwhile, we are late. Okay, so sorry for being that. Actually, I have started the class early, but due to the link was separated, so that's why this happened.
Okay.
So I hope students are now joining. More or less, yeah. So it's Chandigarh region, right?
Yeah, it's Chandigarh region.
Yes. So I think basically, how many students are in your school?
Sorry, can you please come again?
Like what I'm saying is like you are a coordinator or you are a student.
You're a coordinator or actually, I'm the Vignan
So
Jyoti project associate. I'm handling this from NBS headquarters.
okay, okay, Nidhi. Thank you so much for joining. Okay, so like basically, that today is National Girls Day, Girl Child Day. So we are a little bit of celebrating with the students. So today many people are going to join. And along with that, we have some students joined from YouTube, right? So basically, I would like to start the class. It's quite late because of technical issues and all. So I think it's good to go. So students, people who are going to know the basic things about galvanic cell, Daniel cell. We have discussed all this stuff in the previous class. So if you people know about this, please do reply in the chat box. If you have any doubts, any queries, if you have, so please do tell me in the chat box too. Okay. So hi Hanisha, how are you? So my dear YouTube friends, if you have any doubts also, you can reply me in the chat box. Yes. Okay. So in case if you are facing any issues also, please let me know. I'll sort you out. Okay. So basically in the previous class, we have discussed about galvanic cell and Daniel cell Salbridge cell reaction. So it's nothing but electrochemistry basic introduction, right? Yeah, we have starting to discuss about electrochemistry, basic things we started. So that is how the reduction is happening, how the oxidation is happening, why increase in oxidation number is called as oxidation. So these basic things I have discussed earlier, right? So now, I would like to tell you today. Basically, I've told you last time galvanic cell, right? I told you about galvanic cell. So, in basically the main function of galvanic cell we talked about. So, the main function of galvanic cell, it will convert the chemical energy to electrical energy. Okay, will convert the chemical energy to electrical energy, right? So this is what the thing is. The main function of galvanic cell is to converting the chemical energy to electrical energy. So, and next, basically what we are going to do is like we read about the main principles of a galvanic cell. There is an anode, there is a cathode and all. I will revise you. So you are going to have a setup, right? So this we are going to call it as anode. So basically what exactly happening in anode, that is oxidation. It will going to lose the electrons, right? So we are using the zinc metal. We discussed this one. So what it exactly do? It will lose two electrons by producing zinc plus ions inside the solution. Okay. So the Zn plus 2 concentration will increases inside the solution. And later on, we have connected with another thing that is called as cathode. Okay. So that particular cathode is on also an electrode. So what is the main function of cathode? It will try to gain the electrons, okay, and deposit as copper. So whereas inside the solution you are having the copper ions, okay, this copper ions will going to consume two electrons, okay, and forming as a copper solid. That is nothing but deposition of copper will take place on the surface of cathode, right? We discussed this point, and we have connected with a voltmeter whether the current is passing or not. So we got to know that the electrons are moving in this direction, So when the electrons are moving in this direction, we can conclude that the current will flow in this direction, right? If you are making this, so this particular setup, after some time, in this particular anode, you have observed that zinc concentration will increases, and simultaneously in this second electrolyte, the copper ions will concentration will go on decreases, right? This is what we have seen. So basically, in order to avoid this issue, we are using a thing called as salt bridge. Okay, so we use it, that is a salt bridge. So this is what salt bridge is, nothing but a basically agar-agar solution. So where the ionic mobility of ions will take place, this we have discussed. So my dear YouTube friends, please do reply in the chat box too. Okay, if you have any issues. So I'm checking the YouTube also, right? Okay. So there are some students asking me about Zoom links. So I don't know you people, if you are at home, it's better to use YouTube, because in further if you miss any points also you can recall it. Okay. So that's what I was my point. Right. So yeah, basically we have discussed about the main function of this one. So then we started seeing about the salt bridge importance. Again, I'll discuss them furtherly. Then we see about anode and cathode. What is the function of anode? It will go on decreasing its size, or we can say the mass of anode will decrease. This the reason because it will lose Zn plus ions inside solution. And where if you can observe the cathode, so the cathode mass deposition of copper will take place, whereas in case of anode, the reduction in the size and as well as the mass of anode is taking place when you are talking about galvanic cell. This is the basic common sense we all people need to know. So my dear YouTube friends, I hope you people are also getting what are the things are going today, right? Yeah. So in case if you have any doubts, so you can ask me. So I'm getting some students response here. So yeah, it's clear. Very good. So from YouTube also, I'm getting the responses. So whereas, yeah, Anisha, if you have any doubts, or if you people are having any doubts from the YouTube Zoom also, you can let me know to the chat box. Okay. So now, yeah. So overall cell reaction we talked about. Okay. So then you can also see that I told you the trick how to remember this one. Okay. That is lone. That is loss of electrons, right? So usually takes place at anode. So left oxidation, anode negative we talked about, right? And simultaneously that is left oxidation, anode negative, right? This is occurs at anode. Why the negative? The meaning of negative is simply nothing but the charge. The polarity developed on the anode is negative. The only reason is whenever it is losing Zn ions, whenever it is going to lose Zn plus 2 along with 2 electrons, these 2 electrons will be form on the surface of the uh, on the anode. Okay, so that's what I'm telling. Okay, so next, I told you how to write the reactions. So how to write the reactions? Basically, what you people will do, we simply check the reactions occurring at the anode. So you can see the zinc is going to lose 2 electrons. So if you observe this one, I represented like this. So the meaning of this one is 0 to plus 2. So that means zinc is losing 2 electrons by getting the positive charge. So that means increase in oxidation number. So the oxidation number is increases. So hence I am going to call it as a oxidation reaction. Whereas if you have seen inside the copper sulfate solution, you are having copper ions which are going to consume two electrons, which are basically come from the anode. So it leads to formation of copper on the surface of the cathode. Clear? So if you have any doubts, you can also tell me in the chat box. So whereas many people are asking the doubt, so what is the meaning of M here? So the meaning of M is nothing but it is molarity, or we can also say that concentration of the electrolyte. What is that? Concentration of the electrolyte. Clear? This is the concentration of the electrolyte. So my dear YouTube friends, if you have any doubts, you can raise in the chat box too. I'm checking your doubts. whether you are having it or not. Okay, so let me check in the YouTube also. Yes, so there is no doubts at all in the YouTube. Sneha Rani is mentioned. Very good. Yeah. So now, basically, overall reaction we have seen. So that is zinc is going to become Zn plus 2 and copper ions is going to form as copper. So the net seal reaction will be writing like this. I'll explain you in brief in the coming slides. Okay. So this is the setup we have seen. Yeah. So now let us go further. What we are going to see. Yes, we talked about salt bridge. Basically, salt bridge is simply nothing but a inverted U tube, okay, which is going to contain these kind of electrolytes like KNO3, KCl, and NaNaCl. The reason why we are using this because of the mobility of these ions are very good in order to compensate the positive charge inside the anode. So what will happen for the K plus? K plus will move towards to the anode, okay, side, anode side, not towards the anode side. So whereas you have observed zinc concentration will further increases, sorry. So this K plus ions will move towards the cathode. The reason because why it is moving towards to the cathode side, because copper ions are going to be suppressed, or we can also say the copper ion concentration will decreases. Okay, when the copper ions concentration is decreases, we have observed one thing that to compensate this positive charge, this K plus ions will travel towards the copper ion. Whereas if you see zinc plus concentration increases, that means sulfide concentration will decreases if you are using sulfate or if you are using nitrate. So in order to compensate this one, you are going to travel the negative charge towards the anode. So indirectly we can say the mobility of cation is equal to mobility of anion. This question is asked in NEET 2017. So my request to every students, my dear YouTube friends and my Zoom friends, my request is that whenever I will say NEET or previous year questions, you please make a note of it. Okay. Yes. So yeah, thank you. So now Tahana and Asra has joined the session. So like I would like to take another 2 minutes, then I'll make you as host so we can proceed. Okay. So sorry for that because students are asking in YouTube. So just 1-2 minutes, I'll make you as host. So guys, so now completing this electrical circuit. So as I told you, without the salt bridge, what will going to happen? The concentration of zinc, the concentration of zinc ion will go on increasing in the anode side, or we can say left side. Whereas if you see the concentration in the right side, the concentration will go on decreases. Copper ion concentration will go on decreases. The zinc concentration will go on increases. So in order to balance this both things, we need to use a connection between them. That connection is called as salt bridge. Clear? So that salt bridge is also used as an electrical neutrality of both electrodes. So that means in order to maintain the neutrality of the galvanic cell, you are going to use salt bridge. Okay. So the main essential function of salt bridge is you are going to have a inert electrolytes like KNO3, KCl, and NaCl. These are going to help by moving towards the anode side and cathode side in order to maintain the electrical circuit completely in completion. And next one, it will maintain the electrical neutrality and maintain the spontaneity of the cell reaction. Okay, this is the main function of the galvanic cell of salt bridge. So salt bridge is nothing but complete the circuit, maintain the electrical neutrality, and helps in maintaining the spontaneity. Okay, thank you so much. Now I am making you as a co-host, Asra, and then Sahana also. So guys, if you would like to share some of your views, so very good. Okay, so my dear YouTube friends is also ready to hear you. So I'm requesting you to guys to share your views. Okay. So before that, happy National Girl Child Day to everyone. So we're very proud to be part of it, Vignan Jyoti. So I request you guys to share some of your views. Asra and Sahana, can you hear me? If you are
Yes, sir. Yes,
facing
sir.
any technical issue, yeah, you can tell me. You can do.
Yeah, a very good afternoon to everyone. I'm Sahana Al-Nayak from IIT Madras second year chemical engineering, BTech. So I'm an alumnus of Jawahar Navodaya Vidyalaya Hasan. I was guided by Avanti faculties. And a happy Girl Child Day to everyone, National Girl Child Day. Like, I just wanted to add a few things like, why is this day significant for us? What should we to understand like national people, the significance of girl child, because we can see in each home there will be a mother, child, like sister, or anyone. Everyone will be knowing the importance of girl children or a mother in the family. Like from taking the guidance and then the love they give us, those are the main things. And more than that, upbringing a family is the main thing. So like the significance of this day is, like, if you're upbringing your family, like if you are educated, then whole family will be educated. So the program was introduced, Beti Bachao and Beti Padhao. That's not a simple program. It's like it was a main program to just make girl children educated. And why is that important? Like, if a girl child is educated, she'll upbring a family well. Like, education doesn't mean that you have to study science, social, or something like that. It's a way of living, and it's the way of the understanding ideologies in your life. So I would like to say that, like, you have to work hard for this. I guess all 11th and 12th students are there. So I would like to say that, like, what's your contribution on this day? The thing is, if you study well, if you upbring yourself in a very good manner, if you upbring yourself as a well-mannered girl in the society, you're giving you're giving a very good contribution to the nation. Because from you, your family will be educated, and not only in terms of education or something, and you can also help others, motivate others, and you can be a role model in your family, in society, in India. You have seen Sindhutai Sappal. How she lived her life was really a tough one. You can learn from her. It's not about joining a very good college or something. Okay, like, not everyone joins a very good college. Wherever you join, you have to give your best. That's the motive. And the thing is, you have to not accept the failure as it is. You have to work for it and make it as possibilities. Like, achieving your goal is the main point here. Like, you should not stop till you achieve your goal. You should aim high. If you aim high and if you work hard, then everything is possible. Like, our Avanti faculties taught us, even hard work beats talents. If you work hard, even those talented people who don't work hard, you'll beat them one day, of course. And I would like to give advice that please take Avanti teacher faculty's suggestions very seriously and work hard. You'll do your better. Like, you have the powers and strength to do. Everyone is having problems. You can't just sit and be saying that I have this problem, I have that problem. And at the last, if you don't achieve, they'll not ask your problem what happened on that day. They'll just ask you have achieved or not. So the main thing is, you have to work hard. That's it. There's no other shortcut for that. Okay, so work hard, do your best, give your best, and if you work hard and it doesn't happen, that's a different matter. But if you don't work hard and if you don't get, that's completely your mistake. So I would like to say that work hard. Wherever you go, you'll be like, you have to give all your contribution wherever you go. And the main thing is, you have to contribute to the society, because it has given many things to you. So, like, I said all the best to all of you, and like, best of luck for all your exams and upcoming life. Study well, work hard, and proud to be a girl, and give as much as you can give to this society. And make use of all the facilities given to you by Avanti and your school. All the best. Thank you.
Hello everyone, I'm Asra Gasmia, studying first year MBBS in HIMS Hassan and Avanti Fellow. I want it's in being a girl and work hard to achieve it, achieve something in your life, be independent in your life, like be the way you want. For that you have to study well for now. Study well. If you have any doubts, get it clarified from your teachers. They'll be there to help you out in any way possible. Just go to them and ask for it if you want any help in any case. Be like girls are proved to be mentally more stronger than boys. So take privilege in it. Focus on your studies. It's all about you and you being successful in life, and take control. I want all of you to be responsible for it rather than being dependent on someone else. Rather than we have our we have we have different identities as being a daughter of someone, sister of someone. I want all of you to take your identity as your responsibility. Create your own identity being something in your life. Strive hard for it. There is no doubt that you'll achieve it. In case you don't, there is no regret that because you have strived hard to achieve it, and at least you can justify yourself that you have tried very hard, and you cannot feel guilty at any point in your life. Just work hard for that reason. Success and failure are the second option. Work hard is the only option for now. Just study well, uh, clear your doubts, study well, and if you need any help, ask them out. They'll help you for sure. Thank you.
Okay. Yeah. Thank you so much for your valuable words towards our students. Okay, so I request everyone to to listen to your words. No, it's a very pleasure to meet these people, Sahan and Asra. Thank you so much for your time, and I hope you people are doing really good. You utilize the Avanti as maximum. Try to encourage others like this. I hope you people will do far better, and you'll reach top of your in your life for sure. And thanks so much for joining. And so once again, National Girls Child Day to everybody. So my dear YouTube friends and my students. So we'll continue our class as usual. Okay. Yeah. Hmm. So we have just, yes. So we just started discussing about salt bridge. So basically the main functions of salt bridge we have seen KNO3, KCl and NaCl. These are the electrolytes we are going to use. Everything. Okay. So, and my dear YouTube friends, if you have any doubts, you can ask me. Okay. So if you don't have any doubts, please do tell me. I'm checking the YouTube link once. Okay. Okay. So YouTube friends, please do check this in your chat box that whether you are having any doubts or not. So I'm checking it. I don't feel like many students are having any doubts here. So let me continue further. Okay. Okay, so that is what we have discussing regarding the salt bridge. So just a minute, there is a technical issue from. Okay, so YouTube friends, it's a very thank you so much for joining. So now what we have discussed about the salt bridge, and then we are proceeding with the electrode potential. So basically, what is electrode potential? So it's simply nothing but the potential difference that is developed between the electrode and the electrolyte interface. So you have seen here, this is my electrolyte and this is my electrode. So where you are going to get negative charge on it, and electrolytes you are having zinc plus ions will be there. So then when there is a positive and negative charge, obviously what we are going to observe here, we are going to observe here some of the, you know, some potential difference will occur in between these two. So that particular potential difference is called as electrode. Okay, when there is a positive charge and negative charge is present, you will observe the potential difference. Okay, that potential difference usually called as a electrode potential. So basically, if it is occurring at the oxidation, where the charge of oxidation, you have seen at oxidation, the polarity will be negative. So then we are going to call it as oxidation potential. Okay, so on anode is a negative potential, hence it is also true. And the potential during the reduction positive. Okay, hence the cathode is a positive polarity. So that's why I told you anode we are having negative polarity, cathode we are having positive polarity. The reason because the development of potential will be occurs like that. So then you can see here the electrode potentials are represented by letter capital E. The subscript representing the process is E anode and E cathode. Okay, so E anode and E cathode. So whereas if you see in this case, electrode potentials are represented like this. So E anode is basically occurs at oxidation, okay, and E cathodes occurs at reduction. Clear? So this is you people need to remember. So this is my electrode, and this is the metallic surface, or we can say that interface between the electrode and the electrolyte, where the potential is developed. That particular potential is called as electrode potential. Okay. So now there are two types of electrode potentials. One is oxidation potential, where it is occurs at the oxidation. Wherever oxidation is there, there the oxidation potential is taking place. Okay. So now you can see here. So the potential difference associated with the oxidation half cell reaction is called as oxidation potential. So you can see here zinc is going to lose 2 electrons. Okay, zinc is going to lose 2 electrons. So then we are going to call it as what? Oxidation. So due to this one negative polarity, due to the negative polarity, okay, and there is a potential difference is occurs between the electrode and the interface, which makes a electrode potential. Usually it is occurring at oxidation, so that's why we are calling it as oxidation potential. What is the meaning of standard oxidation potential? The meaning of standard oxidation potential is very simple. That means the oxidation potential is measured in the concentration of the species involved in 1 molar. That means if the concentration is 1 molar, okay, if the concentration is 1 molar, and the pressure if you are taken as 1 bar, if you are taken pressure as 1 bar, okay, if you are taking the concentration as 1 molar and if you take the pressure as 1 bar, so then the oxidation you are calculating is called as standard oxidation potential. So because you are calculating at the anode, and standards like maintaining the pressure 1 bar and concentration 1 molar. That's why you are going to call it as standard oxidation potential. So it is usually represented with capital E subscript of O. Okay, that is called a superscript of O. That is nothing but standard conditions it is following. So for if you see in this reaction, so if you see in this reaction, what you are going to see, zinc is going to lose 2 electrons. Okay, that 2 electrons you are going to represent like this, Zn plus 2. Okay, and this is our anode. Clear? So this is what you people need to remember. Next, reduction potential. Same reduction potential is also same story. What will happen for them? Where there is a reduction is taking place. Where there is a reduction is taking place. Reduction is taking place. So where there is a reduction is taking place, what is going to happen in case of this one? In case of reduction, what is going to happen? So basically the metal ions which are present inside the electrolyte will consume the 2 electrons. That means it will gain the electrons and forms copper. Okay, and forms copper. So if you see the electrode, that is going to be Cu plus 2 is raised to Cu, or we can simply write E cathode. Okay. This is you people need to remember. Okay, reduction. So where the reduction potential. So if anybody asks you what is reduction potential is nothing but due to the presence of the positive ions inside the solution, due to the presence of Cu plus 2 inside the solution, and these electrons are going to be consumed or gained by this copper ions, will going to become copper on the surface of the cathode. Okay, so you may see here gaining of electrons will become copper. So here if you can see Cu plus 2 say Cu ban raha hai. That is if you observe plus 2 say 0 jab hoga, that means when there is a decrease in the oxidation number, then you are going to call it as what? Then what you are going to call? You are going to call it as a reduction potential. So same as I told you earlier, if you are using standard conditions, what is the meaning of standard conditions? So the meaning of standard condition is very simple. So the standard conditions are, if you are taking a concentration as 1 molar, and if you are taking the pressure, as 1 bar, okay, and you are doing the experiment at the room, that is 298 Kelvin. So whatever the standard conditions you are following, the reduction potential is now converted as E naught. So now this is the reduction potential. That's why I'm writing as capital E red. And if I'm writing as capital E red naught, this is nothing but I am calculating the potential at room temperature at 1 bar pressure at 1 molar concentration of the electrolyte. I hope you people understand this one. So my dear YouTube friends, I think you can also understand this particular point. I hope it is clear, right? Okay. So then further, what we have seen? So further, we have seen about standard electrode potentials. So what is, now we have seen the individual electrode potential. One is standard oxidation potential, where you are maintaining the concentration 1 molar and the pressure 1 bar. And now we are going to see it as a, okay, we are going to see standard reduction electrode potential. So if the electrode potential, when the concentration of all the species involved in 1 molar and as well as pressure is 1 bar, is called a standard electrode potential. So the meaning of standard electrode potential is if the concentration is 1 molar and 1 bar, that is nothing but standard electrode potential. Now, according to the IUPAC, standard reduction potential are considered as standard electrode potential. So now you people need to remember standard reduction potentials are simply standard electrode potential. So if I am saying standard reduction potential, you can simply say that that is a electrode potential. Okay. So what is the meaning of standard reduction potential? So whenever you are calculating the potential at cathode, if you are calculating the potential at cathode, that is, you can also call it as standard electrode potential, or you can also call it as standard reduction potential. Okay. You people need to remember this. So next one, the sign of the oxidation and reduction potentials for the same reaction are equal in the magnitude. Okay, that means the sign of oxidation and reduction potential for the same reaction are equal in the magnitude but opposite in sign. Okay, so very simple. Just now I have mentioned here, you can clearly see this is E naught of copper Cu plus 2 is going to become Cu, and if you see here Cu is going to become Cu plus 2 plus 2 electrons. So here this is oxidation and here this is reduction. So that's why we can clearly say that. That's why we can clearly say that. Okay, what is that one? Reduction relation of oxidation is, what is the reduction potential? If the reduction potential standard is given, that is negative of oxidation potential. Okay, very simple thing is like a reduction potential of any electrode is negative of, or you can say that is the reverse of it. Reverse in the sense we can also say that minus you can keep, then it will become negative sign for that. So in other means, if I am going to say, if I have calculated, let's suppose if I have calculated electrode potential of like copper Cu plus 2 Cu. So this we can see plus 2 and this is a phase difference, it is going to become 0. So that means this is a reduction potential, right? This is reduction potential. This is reduction potential. Okay. So when if you see this is a reduction potential, so you can also say that so you can also say that reduction potential. Then if you are going to link with oxidation potential, so that is reduction potential is negative of oxidation potential. That is what you need to know. So then later on we have seen this is how you write the relation. So reduction of Cu plus 2 ion, if you see Cu plus 2 plus consuming 2 electron will give you copper. So this is plus 3.04. Whereas for oxidation of copper, if you see Cu2 says Cu plus 2 हो रहा है, so then it is becoming negative, that is minus of 0.34. This is also oxidation of copper, but it is the negative of reduction potential value. Okay, so just now I told you the main reason for that. So yeah, so now I have some more examples. You can see zinc, it is becoming Zn plus 2 plus 2 electrons, so that's why it is oxidation. That means if 0 say plus 2 हो रहा है, this is nothing but increasing oxidation number, is nothing but what? Oxidation. Okay, whereas you can see Zn plus 2 से क्या हो रहा है? 0 हो रहा है. This is decrease in oxidation number. This is called as reduction. Okay, decreasing oxidation number. This is called as reduction. Okay. So now you can clearly say that. Decrease in oxidation number is reduction. Increase in oxidation number is oxidation. Okay. Now you can clearly see here Ag plus to Ag, that is plus 1 से 0 हो रहा है, reduce हो रहा है, that's why you are going to call it as a reduction potential. Okay, that is what you need to know. So here also you can see zinc, it is oxidation, and if this is minus, then this needs to be plus. Both same symbol, then it will be wrong. Either oxidation potential or reduction potential. You know that both का relation क्या है? Negative sign will be involved. Okay, guys. So that's it from the today's class, and we'll talk about the UPSC representation of this one in the coming classes. Thank you so much for joining. See you. Bye bye.